Litestar is a newish/lesser-known framework for building web services using Python. It promises great performance and many built-in features. Plus, it has a few super nice quality-of-life things, such as its SQL Alchemy plugins. In this video, let's take a look at building a REST API using Litestar. Hi, I'm Jose with Teclado. In this video, we're going to build a REST API using Litestar, run it using Docker, store its data in PostgreSQL, and deploying using Hostman. Hostman is sponsoring this video. More on them later. They make deploying this REST API super easy with their app platform.
Let's start by building a simple Hello World app with Litestar and run it with Docker. That'll get us set up, and after that we can write our REST API code. The first thing you need is Litestar with the standard extra, and create a virtual environment and all that if you haven't already. Then pip install -r requirements.txt. Then in app.py, we're going to say from Litestar, import Litestar with an uppercase, similar to what we would do with Flask, but we're also going to import get, which is the decorator that we're going to use to define our endpoints. Now, endpoints in Litestar are asynchronous, so we'll do async def, and then you can name it whatever you want, and we'll use type hints, such as you do with FastAPI, to define the return value of this endpoint. Usually, this will be a dictionary or a Pydantic model, or even a Postgres declarative model, as we'll see later. But here we're returning a string just to say hello world. Once you've done that, you can say app is Litestar. And now something I really like is you have to pass in the root handlers. So inside a list, we'll pass index. This is our hello world app. Now to run it, go to your terminal and type Litestar run. There you have it. Now this is running on 127.0.0.1:8000. So you can open your preferred API testing tool, or you can use the built-in documentation. Beware, because we're going into light mode. This is the built-in Swagger documentation that's generated from the code. And you can see we've got an index root here. I know this text is a little bit small. Let me zoom in. And with Swagger, you can try it out. So if you don't have a favorite API testing tool, you can simply try it out, hit execute, and you'll see that the response body is hello world. To run this with Docker, I recommend you install Docker Desktop, then create a Docker file, and inside it, we're going to put these contents. We're going to start from Python 3.12, that's the base image. Then we'll copy our existing code into the app folder. Then we'll install our requirements. Finally, we'll expose port 80 because that's the port that we're going to run Litestar on. And this is the command to run Litestar. In Docker, you pass in the command using this JSON list style. So we say Litestar run --host 0000 port 80. And that's it. So it's pretty straightforward to set up Docker if you have Docker Desktop installed. Now you should be able to type the Docker command in your terminal. If you've just installed Docker Desktop, you may have to restart VS Code before the Docker command works in this terminal. We can do Docker build, and we're going to build an image that contains our code, and then we're going to run that image. So we'll say -t to give it a name, Litestar API, and then at the end we need a period to build the current folder into this Litestar API image. So we'll grab that and we get the new image called Litestar API. Now to run a container based on this image, we'll say docker run -p, and now we'll say 8000 to 80 because we want to map our port in our machine, port 8000, to the port in the container, port 80. That will give it the image name Litestar API to target the image we've just built. And there you have it. Litestar run has started, and you can see it's running on port 80. Now, if we go back to our Swagger documentation that was running on port 8000, we can refresh the page and this still works because now we're accessing the program that's running in the Docker container. We can still try this out, press execute, and you'll get your hello world back. If you want the app to automatically restart when you make changes to the code, you have to add another --reload argument in here, and that's going to restart the command whenever the code changes. But when we change the code here, it's not going to change in our Docker container unless we link the current directory with the app folder in the Docker container. To do that, first let's rebuild the image with this extra argument, with docker build -t Litestar API and then the dot at the end. And then to run the container while linking the current directory to the app directory inside the container, we'll say docker run -p 8000 to 80 as we did earlier, and then we'll say -v And if you're on Mac or Linux, you can say $pwd for the present working directory, :/app. And that tells Docker to use a volume which links this directory to the /app directory inside the container. Remember, that's where we've copied everything. So whenever we make a change here, it's going to be propagated into the container live. Then we'll say Litestar API. Instead of $pwd, you can put the current working directory, which is this one here. If you're on Windows, you'll have to do something like C, documents, your project, blah, blah, blah. But for me, I'm going to stick with pwd, and then we can run that. Now you can see the logs here, and if I go into my app.py and save, you'll see the application automatically restarts. All right, so that's well and good. We've got our Hello World app running in Docker. I hope you've learned something by now, but now we're going to build an actual REST API using Litestar with the PostgreSQL data storage. So let me get rid of all of that, and we're going to start from scratch. The first thing that we want to do is define our data model, or what it is that we want to store in our database. Usually with SQL Alchemy, you'll first define a base class, which is your declarative way of defining a table and its columns, and then you'll define a class which inherits from it that defines the actual table name and the various column names. This is using the new SQL Alchemy syntax, so if this is new to you, welcome. By defining this as a class attribute and then type hinting it with mapped and string, this automatically tells SQL Alchemy that we are using a string type column. Of course, we have to add our import, and we need to install some more dependencies. So in requirements.txt, I'll bring in Litestar with SQL Alchemy, PsychoPG2, Pydantic, and SQL Alchemy with AIO SQLite, because we're going to store data in SQLite for now. Later on, with PsychoPG2, we can store data in Postgres. For development, though, SQLite can't be beat. In order to install these new requirements and run our app with them, we have to rebuild the image. So I'll stop that one, build it again, and then restart it again with the reloading functionality and the Docker volume. Now we'll run the app. But you can see that we get an error because we haven't even created a Litestar app or ran it. So there's still a bit more work to do. First, we need to configure the database connection. We need to specify which database we want to connect to, and we have to tell Litestar if we want it to create our tables for us or we're going to handle that ourselves. For this app, we're going to ask it to create the tables for us. Here's what the database config looks like with Litestar. We use the SQL Alchemy async config object. We pass in a connection string, the metadata that is derived from this base class, which defines the different tables and columns in each. Create all tells it to create all our tables when initializing the app. And the before send handler allows us to set the auto commit to true. What that means is that whenever we make changes to an object, it will be committed before sending the response to the client. If we don't have this, we'll have to commit manually. Let's import both of these things. The first one is from Advanced Alchemy, and the second one is from the SQL Alchemy contributed plugin. Now you may see that we're missing some dependencies in here according to Visual Studio Code, and that's because we've been running our app in the Docker container and we've got the requirements installed in there, but we don't have the requirements installed in the local virtual environment. So if you want to get rid of those errors, you can do pip install -r requirements-txt, and that'll be installed and this will all go away. There you go. Now once you've got your database config, we can create our app. At the moment it doesn't have any endpoints, but it does have a plugin. And that is the SQL Alchemy plugin, and we pass dbconfig to it. The SQL Alchemy plugin also comes from here. Now earlier we deleted the Litestar import, so let's bring that back. There you have it. Now we can run our app again. And I've got a typo, so let's get rid of that. Let's try again. There you go. Now we've got our database created. And you can see that it's got this table, to-do items with 3 columns. We've got our app running in our container. Hopefully this already shows you how straightforward things can be with Litestar once you've got the hang of it with the SQL Alchemy plugin. But what's even more amazing about the SQL Alchemy plugin is that you can return SQL Alchemy objects from your API and they will be automatically serialized or deserialized when you are returning data from your API. Let's write an endpoint that gets all the to-dos in our database. First, we'll import get from Litestar, and then we'll say at get to-dos, async def get to-dos, and now we need access to the database. Whenever you use the SQL Alchemy plugin, you can get DB session passed in to your functions. These are dependency injected, so you can access the session of the database in any endpoint. DB session is an async session. We'll import that in a second. And that comes from the SQL Alchemy package itself. Now, going back to our endpoint, we can do async with DB session.begin to start a transaction with our database. And in here, we can say query is select all the to-dos. Then the result is await DB session.execute query, and we can finally return results scalars all. Now you can see that we need to import select, and that's from SQL Alchemy. So we'll say from SQL Alchemy import select. And we need to annotate the return value of our function. And that is simply list of to do. That is the SQL Alchemy model that we are returning. And this SQL Alchemy plugin is responsible for serializing that and including the ID, task, and user ID in the resultant JSON. Now let's save that and the app restarts. We can go over to Swagger, hit execute, and then we see that we get an empty list back. Now we can go back to our app and write an endpoint for creating to-dos. To create a to-do, we'll need something very similar to that, but we'll use a post method. So we'll say to-do, then async def create to-do, and this is going to receive some data. The data it's going to receive is the task and user ID. So we'll say data is to-do, but it's not going to receive the ID because that's generated by our database. I'll show you how to deal with that in a moment. For now, let's assume that the ID is also sent from the client. And we've got DB session, which is async session. And this is going to return a single to-do that we create. We'll say async with DB session begin. Then we'll say DB session.add the to-do, return the to-do itself. Let's import post from Litestar as well and include our create to-do down here in our handlers. You can see that because the incoming data is serialized into a SQL Alchemy model, we can simply include it with add into the session. And because we've got auto commit before send, this gets saved to the database and that's it. There's very little boilerplate and we can reduce this boilerplate further. Let's go and try this out. I'll refresh the page. We've got to-dos. We're going to execute this to make sure that we've got an empty list. Then we scroll down to create to-do and we can try this out. We get our request body here. We're going to include an ID because we have to. The task is going to learn Litestar. The user ID is going to be 15. It doesn't matter what the user ID is because there are no relationships at the moment. And you can see we've got an error. So let's have a look at the error. We've got some async thing, can't call await only, was IO attempted in an unexpected place. So here's the interesting bit. We have actually created our data in our database. So we know that up to here, it's worked. But then when we return data, that bit doesn't work. So there's something to do with the serialization that doesn't work. A nice way to make sure that it is this that doesn't work is to go back to Swagger, go to the to-dos endpoint that now should return one to-do, execute, and you'll see that we get exactly the same error. Now the issue seems to be that in order to serialize, we need to be in a transaction when we return from the endpoint. And here the transaction ends before then. So the solution is to extract this DB session begin to a separate function. I'm going to call it provide transaction because that's what they do in the official documentation as well. And all that this needs to do is to take in the DB session, which is an async session, and return an async generator, which contains an async session and none. Now in here, we can do async with DB session begin and then yield DB session so that any of these can use provide transaction but not begin the session inside the function. So how do we call this and get DB session before we enter a function? Well, we'll use dependency injection. So let's get rid of async with DB session in both of them. And instead of DB session, we're going to call this transaction. Now we need to provide the transaction by running this function and injecting the value when the function runs. To do that, we can go back into Litestar and say dependencies and say transaction is provide transaction. just like that. Now, whenever we use the transaction keyword argument in any of our endpoints, the provide transaction function will run and the yielded value will be passed to these parameters. Now we can use transaction instead of DB session within the function bodies, and we need to import async generator. So at the top, we can do from collections ABC, import async generator. Now what this achieves is the transaction is started before the function runs and closed after the function returns, and then the serialization will work. Let's go back to Swagger and press execute. And now you can see that we've made a typo somewhere. That's here. It should be begin. Let's try again. And there you have it. Now this all works fine. So this is a bit of a weird thing that is not actually mentioned in the docs anywhere that I could find anyway. But there you have it. You need to be within a transaction in order to be able to use the serialization from the SQL Alchemy plugin. And now you've got your list in there. And if we go to create to do and we'll give it another ID, let's say 6, for example, we can execute this and we get our response body as well. The last thing I want to show you is how to allow for generating the ID in the server and not require the client to pass the ID value. What we need to do is write what's called a data transfer object. Data transfer objects are used for serializing and deserializing and validating data. A data transfer object is already in use here, created by the SQL Alchemy plugin, but we can create our custom data transfer object that does not require the ID field to be passed. To create a data transfer object, there are many different ways. I encourage you to check the official documentation. But when we have an existing SQL Alchemy model, we can create a DTO very easily, which I'm going to call write DTO, by simply inheriting from SQL Alchemy DTO to do. And this looks super weird to any Python developer. What's with the square brackets, by the way, in the inherited class? But this is how you do it. Let's import SQL Alchemy DTO, and we need to get that from here. So we'll say from Litestar plugin SQL Alchemy, import SQL Alchemy DTO and SQL Alchemy DTO config. We're going to use that in a sec. Then inside it, we say config is SQL Alchemy DTO config, and we can pass in some fields to exclude. And this is a set of fields that we're passing, and we're passing the ID to say when we are receiving data that the client is trying to write to us, we are going to use this data transfer object instead of the auto-generated one, which uses the 3 fields. We're going to use this one that only uses these 2 fields. So we'll grab write DTO, and here in post we'll say DTO is write DTO. Now we can go back to Swagger, and when we create a new task, we can remove the ID property, and that works just fine. You can see that we've got ID null, task is learn Litestar, user ID is 15. Going back into our database, you'll see the ID is actually not null, it is 7. So how do we get the ID when we return data? Well, we say await transaction flush. We need to flush the transaction to save things to the database, and that is when the ID is generated. And then SQL Alchemy will automatically update our data model. And when we create a new one now, we get ID 8. It would be nice to be able to do this without having to manually flush the transactions, but that is just how databases work. Now let's improve provide transactions slightly, because there is a provided code block in the official documentation that you should probably use. It does exactly the same thing, but encapsulates it in a try except block, which raises a client exception with a 409 and the appropriate level of detail. And this is a bit better just to give some more error handling and some more information in your API, so we can import these things. Up here, we'll need client exception and HTTP 409 conflict, and we'll also need integrity error from SQL Alchemy. So we'll say from SQL Alchemy exe import integrity error. And obviously there's a lot more that we could do with this API in order to make it better. But now let's work on deploying this API and running it in the Hostman app platform. First, go to hostman.com and create an account. I recommend signing in with GitHub so that linking your projects from GitHub and deploying them in Hostman is a bit easier. Then go to GitHub and create your new repository for our Litestar project. I'm calling it Litestar YouTube project. You can choose to make it public or private. It doesn't matter. Just create the repository. And then you want to grab this git remote add. Then over in your terminal, we're going to do git init. And you want to add everything except the SQLite database. You don't need the Python version either. So we'll do .gitignore. We're going to create a new file. And we're going to put .python version db.sqlite. You can do star.pyc. You can do pycache. You can do .dsstore. There you go. Just a few things that you usually don't want to include in your repositories. Now we'll do git add everything, git status. And you can see that I've included accidentally the .venv and .vscode. We don't want to include that. So let's add those to the gitignore and then do git reset. Then we'll do git add everything again. Now we've got the gitignore, docker file, app.py, and requirements file. So we can commit this and then do our git remote add origin and git push u origin main to send everything to GitHub. Now we can come here and refresh the page. We should see our file contents. Now back in Hostman, we want to create a database. But first, we need to create a network for our API and our database to be together and be able to talk to each other. So let's go to Networks, Add Network. Then I'm going to go with the Netherlands because that's the lowest ping. And you can leave everything as the default. You can give it a name if you want. I'm going to give it Litestar API Network. Don't enable NAT if you don't need any public addresses for the services in here. And now that we've got our network, we can go to databases and create a new database. Let's select Postgres. And again, in the Netherlands, you can see that you get quite a powerful server for just $4 a month. If you don't need a public IP address, then select no external IP. Make sure to put it in your private network. Get free backups. That's nice. And then you've got your database name and password. Make sure to put it in the right project. I'm using the default project in here. That will take a couple minutes to create. In the meantime, we can grab the connection string because we'll need it in a moment. Then let's go to App Platform, and you can get a server with Hostman, or you can deploy Docker images on their own. I find that to be quite a bit easier. But if you want to handle the Docker installation and running and Nginx, etc. in your own server, you can do that with cloud servers, or you can use the App Platform. Let's go to App Platform, hit Create, then go to Docker file at the top, and we're going to run any kind of app that we want using Docker. Then simply select the Litestar YouTube project. I've got a couple in there. The branch is the main branch, and we're in the Netherlands. You've got your server configuration and your variables. And in here, we're going to put database URL and put in our PostgreSQL database URL. We're not using that in the code, but we will in a moment. And finally, make sure to put it in the default project and hit Start Deploy. I will say that I've not managed to get this to work in Safari. It only works in Chrome, according to my testing. And I don't really know why that is, but I've spoken with the team and they say that they're working on it. So if you're using Safari, this may not work. If you're using Chrome, this should work. And you can see that that's doing something. And in a moment, we'll get the deploy logs as well. So there you have it. That is now deploying and it's going to run our Docker file when it is ready. So we've got our database and our Docker container going to be running. And we've also got a domain that we can use to access the Docker container. Now, while that deploys, let's go back to our code and make sure to use the environment variable here. We can say os get env database URL. We'll need to import os at the top. And that will simply give us access to the database URL. Now, to work locally, I would recommend creating a new file called .env. Put database URL inside it with SQLite plus AIO SQLite / db.sqlite. And then in your requirements, make sure to add python-env. Go back to app.py and at the top, say from .env, import load.env. Load.env in here. What that'll do is it'll go into your .env file, load the different variables into your environment, and then you'll have access to them when you do os.getenv. Without that, our Docker container will always use a SQLite database. It won't use the Postgres database we've purchased in Hostman. So whenever the container goes down, you will lose your database. If you want to use Postgres to persist your data across container restarts, I recommend that you do this and use a PostgreSQL database. Now would be a good time to rebuild your Docker image in case you want to run it again locally, and also to commit these changes and push them to GitHub. You don't want to include your .env file in GitHub, so the first thing to do is add it to your gitignore, then git status again. There you go, git add everything and add for database connectivity. And then we can push that to GitHub, and in Hostman, this will automatically deploy as well. Something that I forgot to add to our requirements is async PG. We need that for async Postgres connectivity. We do have AIO SQLite, which allows for asynchronous SQLite connectivity, but we need that for asynchronous Postgres connectivity. Then add everything and commit to this. And then you'll also have to go to Hostman, and in your settings, deploy settings, and for your database URL, make sure to add PostgreSQL plus async PG here before the rest of your database string, and then save your data. You'll need this and the new requirement before you can connect to your database. Something I quite like about Hostman is that you can see how things are progressing as you go, and you can very easily roll back to a previous commit if you do introduce a bug, which, as you've just seen, happens quite often. Once everything's deployed, you can go to your Hostman URL, which you can get here, then /schema/swagger, and you can try it out. I've already been trying it out, so you can go to your to-dos, press execute, and you should be able to see whatever's in your PostgreSQL database. And if you want to create more to-dos, you can do so here as well. So this works exactly as we've been seeing all this time, but now it's storing data in your PostgreSQL database instead of a SQLite file. And you can see how straightforward it is to deploy a Docker application using Hostman's app platform. So thank you, Hostman, for sponsoring this video, and I hope you guys check them out.
So what do you think about Litestar? Does it look interesting? Are you going to check it out? If you'd like me to make more videos about it, please leave a comment below to let me know. Thank you very much for watching, and have a great day.